Okay, we're going to start today by going over 4.2 practice C. Number 1, LX is congruent to IW. Then angle I is congruent to angle L. Angle A is congruent to angle G. And the measure of angle I is the same as the measure of angle L. Right? And the measure of angle G is 55, so the measure of angle A is 55. So then 92 plus 55 gives you 147. So you do 180 minus 147, which gives you 33 degrees. IW would be the same as LX. So that would be 4 centimeters. In triangle LAX, now see it started with the middle, then went to the first, and then to the last. It's congruent to triangle I. Start in the middle, go to the first, and then the last. So it's IGW. Number 7, write a congruent statement for any figures that can be proved congruent. Alright, so here we have WX congruent to YZ and XY is congruent to itself. So you know that this whole side WY would have to be congruent to XZ. Then TZ is congruent to VW, and TU is the same as VU, and XU is the same as YU. So you can say that the two triangles are congruent. We say triangle W, VY is congruent to triangle, and then it's ZTX. And that's it. We look at the next figure. This is not a triangle, obviously, but we can check them to see if all the parts are congruent. If all the parts are congruent, it means that the shapes are also congruent. So this side, FC, is the same as HK. So those sides are the same. IH is the same as CD. IJ is the same as ED. And JK is the same as EF. Then if we look at the angle measurements, C is congruent to H, D is congruent to I, E is congruent to J, and F is congruent to K. So then we can say, we'll start with C, D, E, F is congruent to, start with C, so H, I, J, K. And that's because all the pieces are congruent. Okay, find the value of X and Y. So here, we see that C is the same as D, so that would give us 1/2 X plus 1 is equal to 31 degrees. So, start by subtracting 1. I'll write it down here. You get 1/2 X equals 30. Divide by 1/2 or multiply by 2. You get X equals 60. Now let's solve for Y. So E is the same as 129 by the third angle theorem. So 2y minus 3 equals 129. Should be a 9, not a 6. Add 3 to both sides, you get 2y equals 132. Divide by 2, y equals 66. So x was 60, y was 66. Number 10. This angle is equal to 4x plus 2y. Okay. Then this angle here is 90. So this is a tough one because we're going to have to end up using a system of equations to figure out which is which. So let's start with 5x plus y plus 4x plus 2y so if this is 90, it means that these two add to be 90 equals 90. So it's going to give you 9x plus 3y equals 90. And then we already know that 4x plus 2y equals 56. Let me draw a box to do this work in. So we start with this 9x plus 3y equals 90 and 4x plus 2y. Well, we can start by solving either for x or y, or we can use elimination. I'm going to use the elimination method. So I'm going to multiply this top one by 2, which will give me 18x plus 6y equals, and if you multiply the left by 2, you have to multiply the right by 2, 180. This one I'm going to multiply by negative 3 because I want to get rid of my y's. So it's going to give me negative 12x minus 6y equals, and then 56 times 3, 168. Now your y's cancel out, and that would be a negative also, because we multiply by a negative 3. We would be left with 6x equals, then 180 minus 168 is 12, so x equals 2. Now you can take that 2 and plug it back into either equation for x. So I'm going to do 4 times 2 plus 2y equals 56. So it gives you 8 plus 2y equals 56. Subtract 8, you get 2y equals 48. And so y equals 24. So that is number 10. Oops. Things went south here. Number 11. A fellow student says that triangle ABC and triangle DEC, or ABC is congruent to DEC because the corresponding angles of the triangles are congruent. Describe the error in this statement. So the corresponding angles are congruent, but the sides are not congruent. So that's where the error comes in. Sides are not congruent. Okay. Number 12. Suppose triangle RST is congruent to triangle UVW is congruent to triangle XYZ. The measure of angle R is 55. So the first one's 55. The second one's 45. Then what would be the measure of angle Z? So it would be 180 minus 55 minus 45. 55 and 45, that adds up to 100, so your last angle would be 80 degrees. Complete the proof. Angle MNO is congruent to angle OPM, angle NMO, okay, so because we know everything that's given here, MO is congruent to ML. If it's two things congruent to themselves, and it's the same thing, it's always the reflexive property. It doesn't even matter what we're talking about. It's got to be the reflexive property. For the second one, NOM is congruent to PMO. That is by the third angles theorem. If this one's congruent to this, and this is congruent to this, then the third angle has to be congruent to the other one. Then the two triangles are congruent, and it's because all corresponding parts are congruent. And that's it. Okay, number 14, complete the proof. AB is congruent to DC, AB is parallel to DC, AB is congruent to DC, E is the midpoint of AC and BD, and prove AEB is congruent to DE, is congruent to triangle CED. Okay, so AE is congruent to CE, and BE is congruent to DE. Now, I want to know how we know that. We know that by the definition of midpoint. The midpoint cuts this segment perfectly in half. Then angle EAB is congruent to ECD. We know those are congruent because those are alternate interior angles. Anytime you're looking at parallel lines, look back at those angles we did. There's alternate interior, alternate exterior corresponding. This is because of alternate interior. You also know that BDC is congruent to ABD by alternate interior. So it listed them out on the same line. Lastly, you know AEB is congruent to DEC or CED because those are vertical angles. And now the last part would be all corresponding parts are congruent. We definitely have a theorem for that. So you could write the theorem number or whatever. That would be perfectly fine. Okay, get out your notebooks. 4.3, proving triangles congruent by side, side, side. Now, up to this point, we have had to show that everything is congruent based on the fact that all the parts were congruent. Now we're learning a new postulate. This postulate says that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. We don't have to look at angles at all. As soon as we see that the sides are congruent, it tells us that those two triangles are congruent to each other. For example, we have these two triangles. AB is congruent to RS. BC is congruent to ST. And CA is congruent to TR. That's all we need to tell us that triangle ABC is congruent to triangle RST. And if it wants to know the reason for that, the reason is side, side, side. That's all you really have to write. That was just a demonstration that works a lot better in class. Okay, use the side, side, side congruence postulate. We need to write a proof. Now again, you're going to want to pause these videos so you can write it down. I'm not going to sit here and wait for a long time just for you to possibly be copying it down there. But step one is KL is congruent to NL, and KM is congruent to NM. And the reason for that is given. It's told to us. We are told that those two are congruent. So now we have one side congruent of this triangle congruent to one side of this triangle, and we have the second side congruent. Step two is to look for the third side of each triangle, which is here in the middle. LM is congruent to LM. And we know that because of the reflexive property. Anytime something's congruent to itself, it's reflexive. Now we have all three sides congruent, so you can say triangle KLM is congruent to triangle NLM, and the reason is side, side, side. Now let's decide whether the congruence statement is true. Triangle 1, D, F, G. So it goes from D to F, which is the one that has 2 on it, is congruent to HJK. This also has 2, and FG has 3, and JK has 3. The last side is 1, so this would be yes, true. Number 2, ACB. AB is 3, so it would be first and last is 3. First and last here is CD, and that's 4. So it would be no, or false. And the third one, QPT. QP is the same as RS. PT is the same as ST. And QT is the same as RT. So that would be a yes. What are the coordinates of the vertices of a triangle congruent to PQR? So, first for this one, this is a harder one than the other ones. You have to know the length of PQR of each side. So QR has a length of 1, 2, 3. This has a length of 4. 1, 2, 3, 4. And then to find PR, count down and over. So it's the square root, goes down 3 over 4, or whatever these were. So it's the square root of 3 squared plus 4 squared. That gives you the square root of 9 plus 16, which is the square root of 25, which is 5. So PR has a length of 5. So basically now we need a triangle with lengths 3, 4, and 5. Here for A, this one, this does not move. It stays exactly the same. So that's 4. The x value stayed the same, the y changed. That's 4. This part here, the y value stayed the same. The x values changed by 3. And then we have to check the last part. It goes from -1 to -4, which is a distance of 3, and a distance of 4 going from 1 to 5. So it would be square root of 3 squared plus 4 squared again. As soon as you see that it's the same as this, then you know that has to be true. So it's A. Structural support. Explain why the bench with the diagonal support is stable while the one without the support can collapse. Basically, in nature, anything with congruent triangles is the most stable structures. And so even if you look at bridges and things, there's always going to be some triangles on it, like the big overhead bridges, like on 376 going over the river. After you go past the mall, that is made up of nothing but triangles. Without those triangles, this isn't stable, and this bench can rock right and left. And eventually it will pivot right and left enough that you can make it fall. This one, because it has this support in it, is not going to pivot nearly as much. So, I mean, granted, if this was 3 offensive linemen, you could make it, and you were wiggling at the same direction, you could make it fall. But it would take a lot more force to make this one fall than this one. Okay, give your homework a try. I will send a video tomorrow to go over it.